Alright, Econ 200, in this video I'm going to go over homework problems from Chapter 3. There's going to be 3 problems that I talk about. The first will be Facts and Tools, problem number 6. The other 2 are both coming from Thinking and Problem Solving, and that is problem number 3 and problem number 5. So let's begin with Facts and Tools, problem 6, part A. When the price of olive oil goes up, what probably happens to the demand for corn oil? All right, well, let's start by drawing our demand curves for those 2 markets. We're going to have olive oil here. Corn oil here. Okay? Now, both of them have downward sloping demand curves. Draw those like that. And then the problem asks us, what probably happens to the demand for corn oil when the price of olive oil goes up? All right, well, let's start with an initial price of olive oil. Call that P1. We've got our quantity Q1. And this demand curve for corn oil is going to be dependent on what the price is for olive oil. Okay, because the more expensive olive oil becomes, the more attractive corn oil is to consumers. Olive oil and corn oil are substitutes. So if this becomes more expensive, people are going to want to buy more of this at any given price that corn oil happens to be. So let's say that the price goes from P1 up to P2. All right, what is going to happen in the olive oil market is, as the price goes up, consumers are going to want to buy fewer units of olive oil. Right? There's a reduction in the quantity demanded here. But these consumers who are buying less olive oil, they still want some kind of a vegetable oil to do their cooking with, or to consume in some other way. And so these people who stop consuming olive oil aren't going to want to stop consuming oil altogether. Some of them are now going to want to move into the corn oil market instead. And so as this quantity demanded falls, and those consumers start moving into the corn oil market, the demand curve for corn oil is going to shift out to the right. Okay, so there's going to be an increase in demand as the price of corn oil goes up. Sorry, it's going to be an increase in demand for corn oil as the price of olive oil goes up. Part B is very similar, and you can use exactly the same kind of reasoning. Part B, it says, when the price of petroleum goes up, what happens to the demand for natural gas, the demand for coal, the demand for solar power? Right, so now, instead of this being olive oil and this being corn oil, we could just say, well, this is the demand for petroleum. And this is the demand for, let's say, natural gas. As the price of petroleum goes up, it becomes more expensive to produce energy from petroleum, and so quantity demanded for petroleum is going to fall. However, consumers still want to consume energy, and so some of this quantity demanded that leaves petroleum is going to push into the market for natural gas, and also the market for coal, and also the market for solar power. Okay? So as one source of energy becomes more expensive, demand for other sources of energy is going to go up. So that is part B. Let me reset the board really quickly, and then we'll get on to thinking and problem solving, problem 3. All right, here's the wording for problem 3 in thinking and problem solving. Suppose light bright and bulbs for U, which I am shortening here to LB for light bright and B for U, for bulbs for U. Suppose there are the only 2 suppliers of light bulbs in Springfield. Draw the supply curve for the light bulb industry in Springfield from the following tables, which are given in the textbook and I've reproduced here. To create this light bulb industry supply curve, note that you'll add up the total number of bulbs that the industry will supply at a price of $1, then do the same for prices of 5, 7, and 10. Okay, so we've got the price, we've got how many units light bright will supply, how many units bulbs for you will supply, and then in this column we're going to fill in what's the total supplied at each price. This total just comes from summing up the amount that light bright will produce with the amount that bulbs for you will produce. So at $1, we've got 10 from light bright, 5 from bulbs for you. That gives us 15. At $5, we've got 15 from light bright, 7 for bulbs from you. That's 22. At a price of $7, we've got 25 from light bright and 15 from bulbs for you. That's 40. And finally, at a price of $10, we have 35 plus 20 is 55 units. And then we simply take these points, we put them on the graph, our price quantity graph, and that will give us the supply curve. So at a price of $1, which is about here, we have quantity supplied of 15, which is going to be about there on the graph. And at a price of $5, we have a quantity supplied of 22. So $5 is right here. 22 is going to be about halfway between 15 and 30. So that'll put us right about there on the graph. Price of $7, we have quantity supplied of 40 units. That's going to be, 40 units will be about there, and the price of 7 is roughly here. Okay, and finally the price of $10, 55 units. That's about 55, that's $10. And so the supply curve, the industry supply curve, looks something like that. Okay? So we just sum up the quantity supplied from all the suppliers to get the total or the industry supply. Do that for every price, and then we plot each price quantity combination on the graph. All right. Thinking of problem solving, problem 5. In Secrosia, the supply curve for sugar is as follows, and they give you a table. They do not have this middle column, but it's going to be helpful for us when we shift the supply curve, so I've added it in here. The supply curve for sugar is as follows. $30 will result in 10,000 pounds being produced. $50 will result in 15,000 pounds being produced. $70 will result in 20,000 pounds being produced. Now this problem's a little bit confusing. I think they were kind of in poor form in the way they set this up, because this price is per 100-pound bag, but these quantities is not in bags, it is just total raw number of pounds that are being produced. So that means that the y-axis and the x-axis are not measuring exactly the same thing. All right, so I think they could have done this better, but that's the problem as it is given to us. So this graph just plots those points out: $30 and 10,000 pounds, $50 and 15,000 pounds, $70 and 20,000 pounds, and then a line is drawn through those 3 points. All right, it says, under pressure from nutrition activists, the government decides to tax sugar producers with a $5 tax per 100-pound bag. Using the figure above, draw the new supply curve. After the tax is enacted, what price will bring forth quantities of 10,000, 15,000, and 20,000 pounds. Give your answers in the table. All right, I'm going to actually start with the table and then move on to the graph. So remember, this supply curve is telling us at a particular price, what is the last unit that sellers would be willing to sell at that price, okay? And presumably, they'd be willing to sell all the other units up to that point as well, okay? Now, the lowest price that you would accept for a particular unit of a good that you're selling is what it costs you, generally speaking, to produce, at least in the market for sugar, where this is being produced for resale. So, if that's the case, this is going to mark what your production costs were for producing each of those units. And now, if the government is also collecting a tax from you, well, then that tax becomes one of your costs of production, effectively. So that if before you were willing to accept the price of $30 per 100-pound bag to produce that 10,000th pound of sugar, now you're going to need to add in the $5 tax. Okay, now you would not sell that unit unless you were receiving $35 per 100-pound bag. And the same logic applies all the way down this table. If before you would be willing to sell for $50, you'd be willing to sell 15,000 pounds at a price of $50 per 100-pound bag. Well, now that it's costing you an extra $5 per 100-pound bag, you're going to need to receive that extra $5 to produce all 15,000 of those units. That extra $5 per 100-pound bag to produce all of those 15,000 pounds. And then finally, if you're going to produce 20,000 pounds, now you would demand a price of $75. Otherwise, you wouldn't produce all of these. Okay, and you can just go over here to the graph and you can say, well, at each of these 3 points that we had graphed out before, we're going to put a new point on the graph representing now the lowest price that the seller would be willing to accept. So if it used to be $30 for 10,000 pounds, now that's going to go up to $35. And if it was $50 for 15,000 pounds, that's going to go up to $55, and 70 turns into $70. And now we connect those dots with each other, and this is our new supply curve, which I'm calling ST. S with a T subscript, that is the supply curve when there is a tax attached to it. And I recognize that these are pretty close together, but that's because the tax is pretty small relative to the prices that are being graphed along the supply curve. All right? And remember, if there is a tax placed on sellers, then the supply curve just shifts up vertically by an amount equal to the tax. All right? So that is it for the Chapter 3 homework problems. Of course, if you have any other questions that you want me to go over with you, I'm happy to do that either in class hours or privately on a Zoom call. Anyway, take care, everybody.